11.2 spheres, part 2, really. Here's a problem we worked on the board. Find the intersection of this sphere, x minus 2 squared plus y minus 3 squared plus z minus 4 squared equals 5 squared. The center is 2, 3, 4, and the radius is 5, and z equals 3, which is a plane. So we're finding the intersection of a sphere and a plane, which will be a circle. So we normally intersect these two coordinate geometry surfaces by doing some algebra. We're going to take 3, substitute for z, and we end up with this. 3 minus 4 squared is 1. That's 25. 25 minus 1 is 24. So we end up with a circle. Two-dimensionally, it's a circle of center 2, 3, radius 4.9 roughly, square root of 24. We can graph that by, first of all, it's in the plane z equals 3. We go up 1, 2, 3 units on the z-axis. You can draw another xy axis. It's going to be in this plane. And so the simplest thing to do is locate 2, 3. We go over 2, over 3. You can make a parallelogram. There's the point 2, 3. Z is 3. And then we need to travel 4.9 units. I just did an approximate picture here. It doesn't have to be that precise. This would be 4.9, this would be 4.9, this would be 4.9, and this would be 4.9. You can draw through this point a new horizontal coordinate axes to give you the right perspective. And then we put the point, 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 and then connect the dots, and we end up with a circle hovering above the xy plane. Okay, so that's pretty much all there is to it. If this was intersection of y equals, then what we would do is make an axis like this. And if it was plane x equals, well, guess what? It would be a plane along the x-axis. We would go like, and we'd move the yz plane down the x-axis. Here we move the xz plane down the y-axis, so you can adjust accordingly. So that's all for spheres part 2.